off with 5.7, just mentioning a few things. This is one of the questions that we did in class, and so we're going to go over this one again. So we have talked about arctangent and arc functions, right? So for arctangent, we know that we're always going to get a value either in the first quadrant or in the fourth quadrant, right? And if it's in the fourth quadrant, it's going to be in terms of negative, right? It'll be negative because it has to be between pi over 2 and negative pi over 2, which is 3 pi over 2, right? So then what happens is that if we're trying to solve for arctangent and we're looking for a specific, like here, the instructions, this is page from your textbook, page 619, it says use your calculator to approximate the degree measure or radian measure of the angle subject to the given conditions. So we want to solve for a tangent of some angle theta that gives us -9/7 in between pi over 2 and pi, meaning we want it to be in the second quadrant. But when we go ahead and we plug this value in, we plug this into the calculator, we get -0.9098, which is going to be a value in the fourth quadrant, right? And that makes sense in terms of it giving us a negative. Okay, so in general, if you need an angle in the second quadrant and you're in the fourth quadrant with arctangent, you add pi to adjust the result and get the needed angle. Okay, so because we have a quadrant in the fourth, an angle in the fourth quadrant, we want the second quadrant reference angle. Remember, a reference angle is the angle from the terminal side, right? We're looking for some angle theta, right? That would be all of this, right? Because then it would be big enough to be in the second quadrant, okay? And we're gonna have to use reference angle to help us out, right? Okay, so the reference angle is gonna be the absolute value of arctangent of -9/7. So if you get the absolute value of this negative number, then of course you're gonna get a positive number, right? So it's going to be positive 0.9098. That is the reference angle, okay? And we're going to do this more later on in chapter 6 as well. So this is going to happen with arc sine and all that good stuff. We're going to have an angle in the first quadrant, but we're going to want the third quadrant and stuff like that. And so you can always go ahead and just get the absolute value of the angle that's given in order to get the reference angle in the opposite quadrant. So notice how this is diagonal to over here because it's only a distance of pi. Okay, so now that we know that the reference angle is positive 0.9098, okay, then we're going to go ahead and use the fact that in the second quadrant, if you have a reference angle, the reference angle is pi, which is 180 degrees, minus the angle, right, is the reference angle. But this time we're going to have to manipulate it, right, because you're trying to find the theta, okay? But in terms of logic, if both of these add up to 180 and I have this angle, then just do 180 degrees if you're in degrees, or pi if you're radians, which right now we're in radians, and subtract the reference angle, and that'll give you this angle. Okay, so you use the calculator, 3.14 minus 0.9098. That is why the answer is 2.23, approximately 2.23.